Alright, piping trades. Let's read a metric pipe schedule. First off, why would we do that? You need to calculate the weight of pipes in two scenarios. One, the pipes are on a truck or on a shelf or something and they are to be lifted, and before they are lifted you need to rig it up with the appropriate hardware. You need to know whether this lighter duty nylon web sling is good enough to lift the pipes, or should we bring out the heavy duty hardware. You need to know before you lift, and the only way to know is to calculate, because you can't put it on a scale. Second scenario, you install overhead hangers for the pipes and you need to know how much the pipes weigh, just to make sure you have enough hangers for the pipe to carry the weight. Third scenario, you need to calculate the weight of a pipe that is filled with water, and all of the data that you need for these calculations are clearly laid out in a pipe schedule. Let's look at the pipe schedule here. This is a metric pipe schedule. I know this because in the heading most everything refers to metric measurements. Millimeters, metric stuff, centimeters squared, metric, kilograms and meters, everything metric. Except in the first column it says inches. Why is that? Excellent question, I'm glad you asked. It is because in North America all the pipe stock is manufactured in inches, and the metric pipe schedule is just everything converted to millimeters. Nothing is made in millimeters as far as I know in the steel mills. Nobody makes actual metric stuff that I know of. So here is your pipe schedule, and everything in it is metric. First off, diameter nominal. Here, outside diameter. This nominal and this is actual size. What is the difference? Look at these amounts. 10.3, 13.7, these are decimal figures. These are hard to say on a daily basis. So instead, they just call it a 6 mil pipe, 8 mil pipe, 10 mil pipe. Okay? Its actual size is 17 mils, but they just call it a 10 mil pipe. Let's take a look at this one. What this outside diameter concept actually is. Let me just zoom out a little bit. And outside diameter is just measured this way, very simply, like so. We're going metric, so this is gonna be there, hook it on, and 48 millimeters is gonna be close enough. There. That is its actual size. So what you do, outside diameter, this is the actual figure. You go down until you find 48 millimeters there. It is actually 48.26, but I don't have 0.26 on my tape measure, but that's going to be the closest because that's 42 and the next one is 60. So the 48 mil pipe, this one is actually a 40 mil pipe, also known as inch-and-a-half pipe. Whether inch-and-a-half actually converts to 40 is irrelevant. Don't worry about it. That's not how these things work. This pipe is a 40 mil pipe. It measures 46 millimeters on its outside diameter, and outside diameter is again from outside face to outside face there, like I showed you with the tape measure. So that would be the outside diameter actual, outside diameter nominal. So this is what is used to name a pipe with. So like I said, 10 mil pipe, 20 mil pipe, and on the other side we have 50 mil pipe, 100 mil pipe. There's all kinds. And the actual measurements are all, some have 2, some have 3 decimal digits. So that's the outside diameter. Next one, wall thickness. Wall thickness on all of these pipes is different and has to do with schedule. So I'm going to talk about wall thickness with schedule. Look at this pipe, and let me just zoom out for a sec so you can see them side by side. You can see the wall thickness, the difference in wall thickness between these two pipes. This one has a thinner wall than this one. It's not coincidence, it is purposefully manufactured this way. The wall thicknesses here are listed for every pipe size. Let's look at this pipe, which I actually have. This 48.26. So we're only looking at the data for the 40 mil pipe, 48.26 millimeters for the outside. The heading for this one here is schedule, and this one is wall thickness. So we go down, and the way this one reads is 40 mil pipe, nominal. These are the different pipe schedule. 5S, 5 strong, 10S, pronounced as 10 strong, standard pipe or schedule 40 pipe, extra strong pipe, also called schedule 80 pipe, schedule 160 pipe, double extra strong or extra strong, but most people say double extra strong. So these are the different pipe schedules, all 40 mil pipe. They can make it with different wall thicknesses. These are the wall thickness amounts. All have the same outside diameter, but the walls are all different. You can see it's 1.6 mils, 2.8, 3.6. It's getting thicker and thicker and thicker. These 1, 2, 3, 4, 5, 6. These 6 rows here belong, all of these 6 rows belong to the 40 mil pipe or 1.5 inch pipe. And these are the wall thicknesses, okay? Some are made with thinner walls, some are made with thicker walls. That again is the wall measurement, how it is measured. It's really finicky to measure it with a tape measure. It's the best thing to do is look it up on a pipe schedule like that. So that's the concept of wall thickness. Next one, inside diameter. The inside diameter is, here is this picture is measured on the inside. It's really hard to measure it with a tape measure because it doesn't bend easily to it. Best thing to do is look it up in a pipe schedule, and you can see that all of the different pipes with all of their different schedules, 10 strong, they have different inside diameters, and you can see as the wall in a pipe is getting thicker and thicker, the space inside, the inside diameter, is getting smaller and smaller and smaller. It is because the outside diameter doesn't change. So if the walls are getting thicker, the inside must be getting less and less, and it does. Next column, inside area in square centimeters. The inside area is also getting less and less and less. That also means you can put less and less water into the pipe. The pipe's wall is getting thicker, so the pipe is stronger, but you can put less and less water in it. Last 2 columns, pipe weight. Every meter of pipe weighs so many kilograms. That's what this kilogram/m means. Let me just zoom in a little bit. There. Kilogram per meter. That's how it's read. And this is how many kilograms every meter of pipe weighs. You can see that as the pipes have thicker and thicker walls, they weigh more and more. Last column, water weight. This means the weight of water inside the pipe. These figures, it doesn't matter if it's cold water or hot water. Hot water is a little lighter, but it is only showing the difference between cold and hot water is only showing in the 100th place value. So the one is second or third decimal digit, okay? I know it's all gonna add up if you have a tank full of it, but for now, don't worry about it. This water weight is at 4 degrees centigrade or Celsius water, okay? And you can see that as the wall thickness is increasing and the area inside is decreasing, the weight of water that can fit into a pipe is less and less and less because there is less and less space for the water inside the pipe. So that's how to make sense after these headings. Finally, let's look at something. How much does this pipe, a meter of this pipe, weigh? This pipe is a 40 millimeter pipe, and I didn't measure the wall thickness of it, but let's pretend this is a standard pipe. So this is how you read it. You find the 40 millimeter pipe, and then you find a row for the standard or schedule 40 pipe, and you go to the column where you have the weight of pipe listed. You come down for the weight of pipe, and it is this column here. There, it weighs 4.038 kilograms. Every meter of 40 millimeter schedule 40 pipe weighs 4.038 kilograms. Let's do another one. How about this one? This is bigger and heavier. This one is 60 millimeter pipe. So I'm gonna flip it over. This is 60 millimeter pipe. Okay, I don't have it. Okay, let's pretend this is 80 millimeter pipe. And let's pretend this pipe is schedule 10 strong. So you find the 80 millimeter pipe data. You find the row within the 80 millimeter pipe data that says 10 strong. And then you go to the column that says pipe weight in kilograms. So every meter of this pipe is gonna be 6.436 kilograms. Okay, that's how to read a metric pipe schedule, and that's how to make sense of the data in it.